We basically are responsible for the fabrication of inorganic nanostructured materials. We have different methodologies of preparing these materials. We also use devices to fabricate materials. Such devices would include microwave reactor system. It is also a high pressure reactor system. But the advantage of using this is that the heating is homogeneous compared to conventional methods of heating. We can also control the power output that's given. So we are able to change and vary different parameters, and this allows us to have cutting edge over control of the structure, of the size, of the morphology, and various other aspects. Now in this particular lab, this is where we do the preparation of polymer nanocomposite. What this machine allows us to do is to mix polymer with a filler, and a good example will be to prepare a biodegradable polymer which could be used for packaging. This would assist us in ensuring that we've got modern materials that are biodegradable and that will be friendly to our very own environment. As soon as we've prepared nanostructured materials, we do something that we call characterization. This is to get to know all the properties that are embedded in such materials. This is a TriStar machine. It allows us to measure the surface area and the porosity of different materials that we produce. This is particularly useful for the reactivity of nanomaterials. The larger the surface area, the better the material. This room here is called optical room. The reason why we call it that way is because this is where we study the interaction of light with matter. This is Fourier transform infrared. It allows us to determine the functional groups in the material. We also measure the photoluminescence properties, or the emission properties as it were. UV visible, we measure the absorption of the material. We also use the so-called nanolog, which allows us to measure photoluminescence, but over and above, it also allows us to determine the chirality of the carbon nanotubes. This is the X-ray diffraction room. In this room, we measure the crystallinity of various materials. As you can see, we've got two different types of techniques. We've got the wide angle XRD, which is this one here. We've also got the small angle X-ray diffraction. What it does is determine the crystallinity of material that are more complex than your usual powders. This is a scanning electron microscope room, and as you can see on my left, we've got the machine. Now in this particular machine, electrons are accelerated down to the sample. They interact with the sample that's loaded in the system somewhere here. They interact on the surface of the sample, and the output that you get gives you information about the surface of the material that you're analyzing. Typically you would get a micrograph like this. This is a typical micrograph of carbon nanotubes. This is a focal ion beam scanning electron microscope. It allows us to study the surface properties of the material. It allows us to use the focal ion beam to cut across different samples. It allows us to view in three-dimensional the cross-sectional areas of these materials. In here we've got this massive state-of-the-art technique. It's called transmission electron microscope. How it works is that electrons are accelerated from top to the bottom where the sample is placed. It allows us to get a clear picture of the morphology of the particles that we have. We can see the surface as well as the internal part of the crystals. The existence of nanotechnology remained postulation since the introduction, and that was because we didn't have facility that was good enough for us to visualize what nano would be. A few years ago, the discovery of what is known as atomic force microscope and of course scanning tunneling microscope have allowed us to zoom in and be able to see the arrangement of atoms, but also to manipulate them. This is the basis of what nanotechnology is and is known to be today.
Join us now as we explore the facility in more detail. It looks like we're headed for an era of great discoveries and innovation, and you too can be a part of the nano journey.